Hello dear students, today we are continuing our questions from the chapter electric charges and fields. So as we have already done up to question number 113, now we are going to discuss question number 114 and 115. So in this case we are taking two questions together because these questions are related questions, that's why we are taking these questions together. Okay. So now look at the first part of the question. Consider a uniform electric field E. So we have the value of E, which is given 3 into 10 to the power 3 I cap. So the direction of electric field is also given, which is along x direction, that is why I cap. What is the flux through the flux of this field through a square of 10 centimeter side whose plane is parallel to YZ plane? Yes, it's very important, parallel to YZ plane. So this is our first part of the question. So we have given with the electric field E, which is equal to 3 into 10 to the power 3 I cap. That shows that this is a vector, and I cap means it is pointing along. I cap is just to indicate along x direction. Okay. Now we have to find flux. We have to find the value of flux through a square of 10 centimeter side. So side length of the square, which is represented as small letter a, which is 10 centimeter, or you can write it as 0.1 meters. Now we have to find flux, and the equation to find flux, if you are provided with the electric field and area, E A cos theta, magnitude of electric field into area into cos theta. Magnitude of electric flux, which is electric flux, is actually a scalar quantity, so there is no need to explain the direction of electric field, electric flux. So we can find this flux by using the relation EA cos theta. You can find the value of area from the side length. Because it is a square, you can just put a square as the area, which is 10 centimeter is the area, so 10 to the power minus 2 meter is its length, whose square is that. So 100 into 10 to the power minus 4, or you can just write 0.01 meter square. 0.01 meter square is the area, which is in SI units. Now the question is that what will be the angle? Here theta is the angle between electric field vector and its area. So we know area, the direction of area is nothing but it is the normal to the plane. If direction of area is just equivalent to the normal to the plane. So in this question it is given that the square, the figure is the shape is of a square, and whose plane is YZ plane. So the side is having the plane parallel to YZ plane. That means the square is lying along the YZ plane, and it shows that it's a direction of area which is normal to YZ plane. Direction of area is normal to the plane. Here it is mentioned that plane is along YZ, or plane is parallel to YZ. That means A is along x direction itself. That means angle between electric field vector and area vector is 0 degree, because we have already mentioned electric field is along x direction. It is given in the question because it is I cap is there. And it is mentioned that the plane of the square is along YZ plane, and I have already mentioned that area, direction of area will be perpendicular to the plane, so it will be along x direction. So electric field is along x direction, and the direction of area is along x. That means the angle between E and A is 0. Then flux phi is equal to, when you substitute all these things, electric field is magnitude of electric field that we have taken 3 into 10 to the power 3 area, which is, you can take either 100 into 10 to the power minus 4 or 0.01 into cos theta. Here theta is 0 degree. The value of cos 0 is nothing but 1. Value of cos 0 is 1. So when you put these things in the solution, so it will be equivalent to 3 into 10 to the power 3 into 0.01. That is 3 into 10 to the power 3. 0.01 is equal to 10 to the power minus 2. That means 3 into 10. That is 30 will be the flux, and you have to write in proper units. So here the units of electric field is given in Newton per coulomb. In this question it is given in Newton per coulomb. Area is meter square. So you can just put the units in that terms, that is Newton meter square per coulomb, which is the flux when the plane makes or plane lies parallel to the y-z axis. Okay, this is our first part of the question. Now we have one more part for this case. What is the flux through the same square if the normal to the plane, look at this, normal to the plane makes 60 degree angle. Normal to the plane means area, direction of area makes 60 degree with the electric field. That means theta, the next part of the question, it is it's very simple if you know the basic idea. The second part of the question, it is mentioned that normal to the plane makes an angle 60 degree with the x-axis. So this is the angle between x-axis. So that along x-axis electric field vector is pointing, that is electric field is along x-axis, and here it is mentioned that it makes 60 degree with that. That means in this question theta is equal to 60 degree. Nothing else has changed. So phi is equal to EA cos theta, that is E is 3 into 10 to the power 3, A is 10 to the power minus 2, and instead of cos 0 you have to put cos 60. So 3 10 to the power 3 into 10 to the power minus 2, that we have already found, it is 30. So 30 into cos 60, cos 60 is nothing but 1 by 2. Value of cos 60 is 1 by 2. So the answer is 15, and the unit is Newton meter square per coulomb. So this is our question number 114. Now we have question number 115. I have put this along with this question number 114 because what is the net flux of the uniform electric field of exercise 114? So you are continuing from this 114 through a cube of side. Let's look at that. This is cube of side 20 centimeter oriented so that its faces are parallel to the coordinates plane. Its faces are parallel to the coordinate planes. So you have to calculate the flux through a cube. So here in this case it is specially mentioned that all the faces are parallel to the coordinate planes. All the faces of cube are parallel to the coordinate axis or coordinate planes. This shows that the number of field lines entering into the cube is equal to number of field lines leaving the cube. So in this question it is mentioned that you have to calculate the flux through the system, flux through the cube. Here it is mentioned that all the faces are parallel to the coordinate plane. Thus flux entering into the cube is equal to flux leaving the cube. that says that total flux is 0. Net flux is 0. So net flux inside the cube is 0. So this is question number 115. Okay.